Hi guys, today I have an interesting question from the University of Cape Coast. We have here, consider the equation x prime of t equals negative k of t x of t plus f of t x of t given the condition x 0 equals x naught, where k and f are continuous on R on rectangle. A. Find an equivalent integral equation for the equation. So in order to find the equivalent integral equation, we first have to identify if it's linear. Obviously it's linear, so the ODE is linear. Then we need to write it in this form. Okay, so writing it in this form, we have to bring this to the other side. So we take the inverse of this, and that will give us x prime of t plus k of t x of t equals f t x of t. So we have, in comparison, we have this being the same as this. So with that, we find the integrating factor, and the integrating factor will be equals to e exponent of the integral of the coefficient of the y. Okay, so here by comparing, this is the coefficient of the function that we're dealing with. So that means the integrating factor will be equals to e integral the exponent integral of k of t dt. Okay, so this, it's a constant, so we are integrating a constant. So when integrating a constant, we get kt. So we're having the mu of x will be equals to e exponent kt. So now we multiply the equation that we had here. So let me make it equation 1. So we multiply the equation 1 by the integrating factor. So we're having e exponent kt times x prime. So x prime of t plus the same thing here, e exponent kt. So kt, k of t, x of t equals e exponent kt f bracket open t x of t. Okay, so we then compress this. One. Okay, now observing it clearly, we realize that it follows a differentiation. Okay, this is obviously a differentiation, but a differentiation of product, a differentiation by product rule. Okay, so here we have e exponent k of t kt, which is constant. The function, this function is constant, the exponential here is constant, and this is differentiated. But in the other side, it is differentiated and the x of t is constant. So we can compress by applying the product rule. So applying the product rule, of differentiation, okay, this can be compressed. So we have d of e exponent kt x prime of t, x of t equals, then we maintain this e exponent kt f of t x of t. Okay, so this is to just help us easily integrate the equation. Okay, so from here, if we are to differentiate this, we get back what we have here. Okay, so we continue. Now then, what we do is to differentiate. What you do after the differentiation is to integrate. So integrate both sides. Okay, so integrate both sides. Since it's continuous on both k and f, okay, from the equation is continuous. So what we do is we use the initial value given to us, and we use it to create the limit. So we integrate both sides on the interval 0 to t. Okay, now we have the integral of d e exponent kt x of t. Okay, from 0 to t equals the same thing here, e exponent k. Now since we were using k to t, since we were using t, okay, we are using t as the limit, so we change this to another variable. So I will use s. Okay, f of s x of x, so ds, and here to have t 0. So here we also do the same thing for this one. So s, the s here and s here. Okay, so that will be good. Yeah. All right, so integrating this, okay, since it's a differentiation and integration, so they will cancel out. So you have, it means you'll be getting back your function here. So you have e exponent k s x of s, okay, then over the limit of t 0 to t, so equals the same thing. We maintain this, so we have e k s f x x of s ds 0 to t. So evaluating the limit on the function, we'll be having e kt x of t, the higher limit minus the lower limit, so e k 0 x of 0, so equals, maintain this, okay. So now simplifying this, we'll be having e exponent kt x of t. This will give us 1, e exponent 0 1, x naught x of 0 gives us x naught from the condition, so x naught equals same thing, dx. Okay, so we can make x of t the subject, and that's all. So that means you're having x of t equals, take the inverse of this, so you have positive x naught. Then you have this as well, taking the inverse of that, so you have e exponent negative kt x naught plus the inverse effect of this side, so e exponent negative kt the integral of e exponent ks f of s x of s ds 0 to t. So that is the equivalent integral. So you are done. Thank you. I will do the next one in the next video, so you check.